after knowing all this already, I think we are ready to know about trying to use fibers with fabrics all together. So we will mix fibers and fabrics to make it all strong. So it's like a woven method. Alright, so let's talk about it now. Alright, so the main characteristics are all this. Alright, and I think you can. So the first thing is drivability. Alright, so the meaning of this is be wrong, but I think this is the explanation. Alright, for example, you have a flexible fibers. In order to drape it, alright, so you can fit this inside. So you have this fibers arranged like that, and then after that you have another layer of fibers arranged like that. Alright, if you want to drape it, so you have to try kind of bend it across each of them. Alright, you kind of bend it across each of them. So at first I go through this black one, and then I go through this red one, I go through this black one, I go through this red one. As you can see, I'm actually draping it, alright, trying to mix them all together. For example, if I were to arrange, alright, if I want to try to put it in this manner, so I'm putting in like this, okay? Later on you'll get to see what I mean. Alright, so this is talking about the easiness of how you drape it. So what you have is all this now. You see how you go across each of the fibers. You see, so you go across, you go on bottom of this black one, and then you come out from the black one. So it's talking about how you drape it. Alright, so I think this is the meaning of that lah. Okay, so it's the easiness of how you can bend the material. So Kevlar itself, I think is quite tough. So I think later on we'll see how it goes lah. And then compressibility, you want the fiber to be compressible or not. So if you want the fibers to be compressible, then you're going to choose a fiber that has high compressive strength. Then you're going to refer back, alright, to this graph over here. Alright, where compressive, you're going to use something like your IM carbon or your S glass. If you want a good compressive strain, good compressive stress, then you use IM carbon. Alright, take note, this is very important because I think if I'm not wrong, the lecturer say that this will come out in exams. So these are the main characteristics for and factors to select your fibers. Alright, to select for fibers for what? For making fabrics. Alright, so stackability, whether can you stack it up or not. So over here I think the stackability is talking about the restricted set of angles due to manufacturing constraints. Alright, so what it means is that the more your fibers are more thin, alright, or it's very small, the diameters, alright, it's hard to actually wove them together. So you have this thing over here, alright, very very thin, and if you want to arrange them in this direction, it's very very tough. If you were to go microscopic, alright, although it seems like it's moving, it's like this, but it's not actually a line. It can be something like that. Alright, so the more you go into microscopic, alright, the orientation is starting to get a little bit tough. Alright, so in all, when you come to here, alright, although you theoretically you want it to be like that, but it may be something like that. Some of the strains may be over here, and some may be broken. It's not a long one, so it may be somewhere over here, and that's it. Alright, so over here, these are the manufacturing constraints. So if you were to stack on top another materials with something like that, alright, meaning another piece, so I take another piece over here, I have some other manufacturing constraints also, I stack it up all over here. So I stack, and then I have another one, I stack again, and eventually I have certain stuff. So I think the stackability is talking about how you orientate the plies, whether are there any constraints when you orientate the plies, alright, in terms of the angles and things like that. I don't know. Let you think about it. Alright. And wettability by the resin is how well the fibers bond with the matrix. If you think about it, there's fibers and matrix. So how well will the matrix bond with the matrix? Alright, and width and thickness of mass of mat. So the mat later on, we'll talk about the mat later. So Yeah, so let's continue right now. So there is a few types. Four, I think only lah. Okay, later on we'll see whether is it four. So the first one is called the roving. You have a certain row like that, alright, and you spin, 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 spin. Alright, in the end you will get something like a toilet roll. Alright. So as for a chop string map, alright, then it comes with one piece like that. It's not a string. Alright, it comes with a piece, where this piece is with all the materials, all the fibers mixed together like that. So it comes with one so-called rigid piece. It's like, okay, in other words, this one don't look like this one is more like a toilet paper. Okay, this is more like a toilet paper because this thing over here is your toilet paper. Okay, this thing over here is more like your 针线. I mean the one that you use to sew your clothes. Alright, the threads. This type, your threads like that. Alright, so it's totally different from your toilet paper. Alright, your toilet paper is one piece by one piece. The roving one is like a thread by thread. Alright, so next is the woven fabric. The fibers comes with either the roving type or the chop string map type. Alright, and the last type I think is the basic types is the last basic one is woven. So there is, I think it's three types: roving, like your threads; chop string map, like your toilet paper; woven, like your cloth. Okay, and then after that later on there's like the woven roving. Is mixing the woven and the woven together, something like that. So the woven one is like your fabric, so you weave it up together like that. Alright, you have a weave that is, as you can see, is a thicker strands. Alright, and you have a warp, right, where the warp will go through each of the weave. Eventually you'll get that. Alright, so this is just the form of it. Alright, as you can see, the warp is the lengthwise, which is the one going straight down. Alright, so the wave are the transverse thread going in this direction. Okay, so I think this is something that you want to know only. Alright, the rest, yeah. And good thing about woven is that they are very versatile design. Alright, comparatively to chop string map. Chop string map is like toilet paper, that's it. For roving, it is also quite versatile because it's in terms of a one string, so you can mix around. And this is why they mix the roving with the woven. You have a woven roving now. Okay, basic form are three types. Alright, the roving, chop string map, and woven. Then after that, you take the roving and the woven, you mix together, you have woven roving. Alright, and woven roving are coarser, heavyweight woven fabric. Coarser means that, I don't know whether I say it properly, coarser or whatever. As you can see, it's very thick. If it's a very fine one, is you cannot see the dots. So over here is coarser. I don't know whatever. So it's like very coarse. Alright, like a stone like that. Very coarse. You can see it from far, things like that. Alright, so a fine one is like your sand, alright, or your salt, very fine. Alright, your sugar also very fine. Maybe I think salt better lah. The sugar sometimes is quite coarse because it's one bit. Your brown sugar is an example of the coarser type. Okay, yeah, you see your brown sugar is like tilap one. Alright, if you want to talk about fine, talk about salt. Alright, salt on the other hand is way finer. Alright, so there's the difference between fine and coarse. Okay, and for this woven roving method, alright, plain width is the most common. Alright, so remember, plain width is the most common within this woven roving system. Okay, and take note that this is not waist, this is warp. Alright, so the warp, if you still remember, the warp is the long strands, while the width is this one. Alright, so you have to know what is the width and the warps. Alright, so based on this, then you will know the different tensile strength and stress, whatever. All mechanical properties are over here. Okay, and you can compare with the chop strain. Chop strain, as you can see, is just one value. Alright, if you have a warp and weave, which is the woven fabric system, alright, Then as you can see, you can mix all the properties, this thing plus this thing. So in other words, you are enhancing your materials. You are making your fibers more better. So your fibers is something like a composite also now. Alright, so it's quite interesting. Yeah, although it's not interesting, but yeah, anyway, kind of cool lah. Yeah, anyway, so a plane wave, if you were to take a look, alright, this just zoom in a little, is an alternatively passing each other. Alright, so over here, alright, this black color one is called your warp. Alright, while the white color one is called your weave. So your weave may not necessarily be like this shape. It can be this straight line. It's a simple one. Alternatively passing means that the warp, as you can see, two of this, alright, is below the white color one, and then the other two is above the white color one, and then the other two is below, the other two is above. Over here at the transverse one, the weave over here is the weave over here is arranged in this manner. That's it. Alright, but for the warp, alright, over here at the front part, for example, this is above the white color one, and then for the next one, this is now above, this is now above the white color one, this is now below, as you can see. So this is something like an alternate. Alright, hopefully you get the meaning of that. Alright, so in other words, I think I don't need to explain. This is, yeah. So whatever thing that is on top of the, so this is the black one, this is the white one. So whatever thing that is now on top will become below on the next weave. So you become below now. So this is below, this is above. So this is the first weave, the second weave. So you, at first, if you are above, then the next one is below, and then alternatively above again, below again. Alright, so this is a simple plane weave design. Okay, and a balanced weave, I think, would be, we just need to know that the warp and the weave are equal to each other. The yarns are just the lines, and that's all. Alright, the threads, I think. Also, it's like a thread. Now I just realized that I typed salt, then I have this movie, Salt the Movie, by Angelina Jolie. Ta-da! Then the setting weave, alright, I think it will just memorize because I don't even know what the hell it's talking. Alright, but what I can see is that for every, it's also alternate, so it's on top, and then after that below of the warp one time, and then is above again, and then below again, and then above. Alright, so it's for every three warps. Alright, so this horizontal one is called the weave, right? And then, sorry, it's called the weave. I should be right. And then the longitudinal one, the vertical one, is the warp. Alright, so as you can see, every three warps it changed. Alright, it switched sides. So this is just the meaning of that. Alright, the rest you just own self read it out. So over here, I think is somewhat also a bit like equal. I don't know, think about it. Alright, then will be a twirl weave. Alright, by diagonal lines. Alright, so as you can see, it's kind of diagonal. If you think about it, there is this, if you observe just this line, you see, if you draw a straight line, it's quite diagonal, right? Yeah, you see. So over here, the twirl is just diagonal. That's all it is. Okay, a 2 times 2 12 is also a 2 times 2 diagonal lines. Alright, what am I doing? Anyway, so this is 2 times 2. Why? Is because there is 2 of this below this weave. Hopefully you have know what is this already. The white color one is the weave, the black color one is the warp. So every 2 warp, alright, sorry, the first 2 warps is under weave, the next 2 warp is above the weave, and then after that the next one is below, the next one is above. So every 2, so it's a 2 times 2 system. If it's a 1 times 1 is one weave, and then after that another one above it. Alright, and then another one below it, and then another one above it again, like that. Okay, as you can see, hopefully you understand what I mean. So this is below, this is above, this is below again, above. Alright, so this is, later on you'll see that there will be a diagonal system also. Alright, so this is just that. So the next question is, what if this is this diagonal? So I think this also looks like diagonal also, you see. So this is why it makes things a little bit complex for me. Over here, this is not very diagonal, it's a bit sengek. But for the plane width, I think maybe also diagonal, I don't know. Let me think about it. Knitted is just knitted, alright? Just like your knit cap or your knit jacket. It's just knitted lah. Yeah. And it can be tailored to individual customer requirements, high proportion of looping, I don't know what the hell, and poor mechanical properties. So what the lecturer says is that you just, if you don't want to remember everything, you just remember the red color words. Alright. And high proportion of looping, I would believe, is the loop over here. If I were to zoom in over here, alright, they actually loop around, you see. It loops with this and with this and with this, so they loop all around. So the looping actually causes trouble, because if you were to pull, the looping will actually break. Alright, if you think about it, the fibers are quite brittle. Alright, so once you pull it, it can actually easily break the material itself. So over here, this is why it has a very poor mechanical properties. Alright, but so if it's good, I think if you could use a glass fibers, which is pretty flexible, so that during your looping, alright, you won't actually break the material. Alright, things like that, I don't know lah. And then braided fabrics, I think you can own self see already. Alright, it's very nice, it's a very netted form. Wow, such as, so the keywords is over here is a protruded parts. Alright, so a protruded parts, if you were to take a look, is like your, something like this. It's a constant, you see, it's like your H or your H beam or your T beam. Alright, these are all protruded materials. Alright, because it has a constant cross section. This is what it says lah. Alright, protrusion is a continuous process with constant cross section, you see. So it's trying to manufacture a constant cross section. Alright, so this is applied when your braided fabrics, alright, is a flat one. If it's flat, then you use for this type of purposes. Alright, and the last, is it the last one? Yeah, the last one is a non-cream fabric. Alright, where is a roving type. Alright, and the key thing is that it reduces kin stress. Kin stress is let's say this is the material. Alright, kin stress is normally talking about when being compressed. So if you were to apply this thing, alright, the material could actually bend in this manner. Alright, so this shape over here is a kin. Alright, it's a kin. As you can see, this is like a step shape. So you can, so this kin, so when it reduces kin stresses, this means that it can allow kinking to apply. Kinking, but anyway, kinky. So it can allow kinky curvatures to apply, and this is why over here, this is, although it's kin, but it's still able to, it still have certain amount of stress capability to tahan stress, or to take in stress. Okay, and therefore it allows the fabric itself to shear easily, alright, and therefore draped into complex shapes. Alright, draped into complex shapes, meaning, as I say, you have this fabric over here, and then if you were to put it over here, and then over here you go over this material. Alright, it's pretty flexible, so since it's flexible, shear easily, this means that it can be formed into complex shapes. Alright, and therefore, yeah, and still have so tissues, felts, and vells are mats, and mats primarily used to improve the surface appearance. And mats itself, if you remember, is your chop strain maps, or in other words, like your toilet paper like that. Alright, so this is why it's very similar to your tissue. This is your toilet paper, or CSM. Alright, so therefore your tissues, yeah, it's pretty light, but I don't know whether is it our tissue or not. Alright, but anyway, yeah, So it has a very smooth surface and things like that. I'll not go into details, but thing is that it has a EM shielding, alright, where if you have a metallized fiber, alright, so you can have electromagnetic shielding where you can apply it to prevent electromagnetic uh, so-called conduction, things like that. Alright, so like a microwave. So I think microwave you can use this type of material so that you can prevent any microwave uh, electromagnetic wavelength or electromagnetic system to leak out of the microwave. So you have a tissues to actually somewhat you know make things good. And nonetheless, you can mix everything together. You have a hybrid over here. Alright, so Bolognese there is a pre-form where he say that he will go through in the future, but I just need to know that you can form to desired shape also. Alright, if I didn't remember wrongly, pre-form is applicable in aerospace industry. Alright, so at first you have this shape, then you pour in whatever thing that is to fill in the shapes. Alright, then after that you compress it already, you heat it up. Once you heat it up already with high pressure, or you pressurize it, and then you form the shapes. So once you form the shapes, then it's just that thing. So it's pretty so-called widely used in aerospace, because I think I've done that before. So as you can see, these are the preformed materials, alright, things like that. Okay, it's quite a lot of information. So what I decided is that I'll do a summary, that I'll compile everything and all the key points into one system or one video, so that it's easier for you to refer in during your revision. Alright, so I shall see you there then.